The world is full of things. All kinds of things. We don't necessarily need them all, but they're here anyway. And the thing these things have in common? They've all been made by somebody. But how are they made? Factories come in all shapes and sizes. The types of production, broadly, fall into three categories. Job, or one-off production, could be a musical instrument, a hot air balloon, or even the mighty Three Gorges Dam in China. Then there's batch production. That's for sets of things, and then changing to do other sets of things. And thirdly, continuous flow, for when you want to make lots and lots of the same thing non-stop. The categories seem straightforward, except that in the real world, it isn't quite that simple. There are all kinds of variations on these three basic categories, as we shall see.
The viola da gamba died out completely in the late 1700s, so the original construction techniques were lost completely. When it was again taken up in the late 19th century, we adopted a lot of the techniques that were used in violin making, but I've recently been making them slightly differently.
Job production, one-off manufacture, is the most specialised form of production and often the quirkiest. It can also take a long time.
It's a very simple instrument, a very simple undecorated violin, for example. If I'm really going for it, I could probably make it in 3 to 4 weeks. But for a highly decorated instrument that requires a lot of research, it can take a long time. It could take years really.
For Shem, the method of production is always developing. He's changed his approach over the years.
I now try to very quickly get the instrument together. I put it together without decoration and without finishing as quickly as possible. And then I've got a whole, I've got a unit to work on.
This handcrafted kind of production is also unpredictable.
I think the one aspect that all makers will agree upon is in finishing. By finishing I mean the varnishing. That it's one of those elements that you can never ever think you've got it 100% down, so that every single time you varnish an instrument you're not entirely sure what the outcome is going to be, because it's dependent on so many different factors. The weather, can affect it. The dust that's in the air at the time, it's just one of those unknown quantities.
Batch production is for making sets of things. Maybe a lot, maybe just a few. How about loaves of bread, deep-fried jam donuts, or these creamy things? They're all made in batches. This is Glenn, head of the bakery in a Sainsbury's supermarket. He likes making things.
To me, I start with a bag of flour and I end with a loaf of bread. So I start with basically nothing and then with an end product, an end fresh product, which I know a customer is going to want to buy.
They use yeast and flour, water too. To make this stuff, dough. And out of the dough, they're going to make things.
It's basically what's happening now, the dough is dropping down through the hopper. Inside the machine, we've got little moulders, so it's moulding each individual crusty roll, which will then come along and come out on a conveyor belt.
So out comes the dough in the shapes they want, ready for cooking. And that's how the bakery makes a batch of rolls. But the point of batch production is that using the same basic equipment, the bakery can make batches of other things, like loaves of bread and donuts. And this same process of batch production is applied to all kinds of other products too, from printed circuit boards to chocolate bars, to home entertainment systems. It may not look much like a bakery, but the production principle is the same. Instead of rolls and donuts, Arcam make batches of DVD and CD players.
Well, we're quite a low volume manufacturer, so we don't operate the traditional product assembly flow line where we've got maybe 50 people working on a conveyor belt. We've got a much smaller team of between 6 and 8 people assembling batches of products from 10 at a time to up to 100 at a time. And those people are involved in the assembly of the products, the testing of the products, and also the quality control of the products.
This is the factory that makes one of the most vital components that go into Arcam's products, the PCBs, printed circuit boards. These too are made in batches, typically 1,000 a go. They have to make different types of PCBs, and in this they come up against the big problem of batch production, the changeover. In other words, the time it takes to set up the machines to change from making one type of board to another.
We could typically run a batch of 100 PCBs in 15 minutes once the machine gets up and running, whereas the changeover process can take 45 minutes. So the smaller the batches, the more expensive they become just because of the setup times, really.
Common to all forms of batch production is the idea that you use the same people and equipment to make batches of different things. But what if you just want to make umpteen numbers of the same thing? Continuous flow or mass production, whatever you call it, it's the classic, most well-known type of manufacturing. Henry Ford and his Model T car is a famous case. You make the same thing non-stop. Making cars is the most famous example, but there's loads of others. From toothpaste to pens and crisps. With continuous production, the emphasis is on speed. The making of the product is broken down into small, straightforward tasks, done either by human beings or machines. The point is to produce as much as you can, as quickly as you can. So those are the basic types of production. But how do you decide which method to use? The biggest factor, of course, is the product itself. You couldn't mass manufacture this, even if you wanted to. So you have to make a dam as a one-off job. On the other hand, how about plastic beads? Cheap and cheerful. If you couldn't mass manufacture them, they probably never have happened. Between these two extremes, there are lots of products where the type of manufacture depends on considerations of complexity or specialization. For example, you can mass manufacture musical instruments, but not a musical instrument which sounds like this.
This is a 6-string bass viola da gamba built in the English tradition, the original instrument, the one that I copied. Dates from around 1620, made by a maker in London called Henry Smith.
What would happen if you tried to mass produce it?
You'd lose the humanity that's in instruments. You'd lose the individuality. You would lose that, well, soul.
Crisps can be mass manufactured, and are, in their millions. These are the type of Bog Standard Crisps you see everywhere. But if you want a more unusual, quirky type of crisp, like these, the upmarket Tyrrell's brand, you have to make them in batches.
With a continuous system, all the chips look nearly identical. They're flat, they don't look appealing. Where with this type of system, they're curled, they're different shapes. You can have a flat one, a folded over one, a not curled one. They'll come to a slightly different colour because of the slice thickness they come through. So it's just totally different.
Another example is DVD and CD players. Your common or garden ones are mass manufactured in huge numbers in China. But if you want high quality ones for the hi-fi buffs, the stress is on high quality, low numbers.
Yeah, in order to get the best possible audio performance from electronics, you have to lay the electronics out in a certain way. Yes, you can reproduce the sound by putting the right components onto a PCB, but it's the way that you put those components on, the space and the orientation of the components and the layout of the PCB tracks that makes the difference in the audio performance. So we take a great deal of care over laying out the boards to optimize the audio performance of the products.
But not anyone can do work like this, which is why a big part of batch production is getting and keeping the people with the skills to do it. Back in the early days of industry, mass manufacturing was based on cheap labour. In other words, a plentiful supply of people ready to work for low wages, whatever the conditions. And it didn't matter how young they were or the risks they took. Over the years, workers have organised themselves to fight for better conditions and more wages. But bosses have still cut costs by investing in automation. And of course, for a boss, the great thing about a robot is it doesn't go on strike for higher wages. On the other hand, batch production, such as here at Arkham, is based around a skilled human workforce.
We have a small team of people here at Arkham who have been building Arkham products for, in some cases, 20 years. They understand the quality that our customers demand, and they're always on the lookout for any defects in quality, whether it be material defects, manufacturing defects, or product performance problems.
Connor Solutions in Tyne and Weir make the PCBs that go into Arkham's products. How important is it to them to have a ready supply of skilled workers?
Well, it's absolutely critical. Having access to experienced buyers, experienced engineers, and having a constant pool of people that we can draw on is critical. You absolutely have to have that.
When it comes down to job production, you'll probably need the most skilled workers of all.
I've been 20 years at this, making instruments, but I can honestly say that it's only within the last 5 years that I've reached a happy point where I'm comfortable with my skills and comfortable with producing work that I'm very, very happy with. So I suppose it's taken me 15 years to reach that point where I'm happy with what I do and find it easy.
Crucially, of course, skilled work like this comes at a cost.
For a treble viola da gamba, it's around 3,500–4,000. I would have thought would be quite the norm. Up to, for a bass, around the 6,000.
So job production is likely to need the most highly paid of workers. But there's another important cost in manufacturing too: the capital